In the world of quantum mechanics, the smallest scales of reality are governed by strange and counterintuitive laws that challenge our traditional notions of what exists and what doesn't. One of the most fascinating examples of this is the idea of quantum foam, the notion that even the emptiest vacuum of space is actually teeming with tiny, vibrating particles. So, let's start with the basics. What exactly is quantum foam? At its most fundamental level, quantum foam refers to the idea that space itself is not a blank canvas, but rather a seething, frothing brew of tiny particles and fields. These particles, which are constantly popping in and out of existence, are governed by the laws of quantum mechanics, which describe the behavior of matter and energy at the smallest scales. One of the key features of quantum mechanics is the concept of uncertainty, the idea that we can never know the precise position and velocity of a particle at the same time. This uncertainty is encoded in what's known as the Heisenberg uncertainty principle, which sets a limit on how precisely we can measure certain properties of a particle. But it turns out that this uncertainty doesn't just apply to particles themselves, it also applies to the very fabric of space and time. According to quantum mechanics, the vacuum of space is not really empty at all. Instead, it's filled with a constantly fluctuating sea of virtual particles, which are created and destroyed in a never-ending dance. These particles are not just theoretical constructs, they've actually been observed in experiments, where they can have real effects on the behavior of other particles. For example, the famous Casimir effect, which is caused by the presence of virtual particles, can cause two parallel plates to be attracted to each other. But why do these particles exist in the first place? According to quantum mechanics, the energy of the vacuum is not zero, it has a certain minimum energy level, known as the zero-point energy. This energy gives rise to the creation and destruction of virtual particles, which are essentially fluctuations in the zero-point energy. These fluctuations are completely random and unpredictable, but they follow certain statistical patterns that can be described by the laws of quantum mechanics. So, what does all of this mean for our understanding of reality? Well, for one thing, it means that even the emptiest vacuum of space is not truly empty, it's a seething cauldron of particles and energy. But perhaps more importantly, it challenges our traditional notions of what exists and what doesn't. If the vacuum of space is not really nothing, then what does it mean to say that something exists? Is there really such a thing as nothing at all? Don't forget to like and subscribe for more videos.